Alright, so this is our last lesson on quadratics, and you're not normally going to see these a lot, but they do appear on the ACT and other classes if you go take like pre-cals and all that. So I wanted to show it to you, not that it's a big deal in our class, but you might see one on the next test like this. So this is quadratic inequalities, and our learning target, I can graph and solve quadratic inequalities. So I'm going to show you, it's hard to explain. I'm going to show you how to do it in Desmos, but there are algebraic ways of doing it. So algebraically, step 1, you would find the axis of symmetry, because that's always important to know, and the vertex. You would use your calculator to generate a table of values, and you would graph the parabola. So you would use a dotted line whenever you have less than or greater than symbols, and you would use a solid line whenever you have less than or equal to, greater than or equal to. So this is very similar to when you did linear inequalities in Math 1. It's just now quadratic, but it works the same way. You're still going to shade where the answers are. Okay, and you're going to use a test point to determine where to shade. However, we're going to use Desmos because it's super easy and it shades it for you, and then there's no question about it. Okay, so here's the first one. Graph the following quadratic inequalities. Shade to show the possible solutions. All you have to do is go to desmos.com/calculator and type this in. So go ahead and pause the video and try it in 1, 2, 3. Alright, so this is what should pop up. Okay, notice that you have the dotted line because you have the greater than. You don't have the greater than or equal to. And then you shade in the middle, which means any point that you pick right here in that shaded area would be a solution. Like if I chose this point, that point is 0, 8. This is my x and my y. And if I plugged this in, it would work. So I'm going to replace the x's with zeros. Alright, so 0 squared is 0. 0 plus 2 times 0 is 0. 0 plus 1 is 1. 8 is greater than 1. That is a true statement. That means any point that you pick in here and plug it into your quadratic inequality is going to make a true statement. Alright. So same thing with this one. I want you to graph it in Desmos in 1, 2, 3. Alright, so notice you now have a solid line because you have greater than and equal to. And what you're saying is if I pick a point anywhere in that shaded region and I plug it in, it would work. Okay, we're just going to do a couple more so you can understand Desmos, and then we'll make it a little bit harder. So here's number 3. Try it in Desmos. Pause the video. 1, 2, 3. Alright, here's what you should get. Still remember that your shaded region is where the answers are. And you have a dotted line because you just have a less than sign. Alright. Here's another one. Graph it in 1, 2, 3. Alright, so once again, the shaded part is where all your answers are. You have a solid line because you have less than or equal to symbol, just like when you do linear equations. Inequality, sorry. Okay, so now let's look at number 5. Okay, so number 5, notice it doesn't have just the y variable on the left side. It actually has a 2x squared, and on the other side 15x minus 27. Okay, so I want to see the difference in these. So go ahead and graph this in Desmos, and then we'll talk about it. So do that in 1, 2, 3. Okay. So when you do this in Desmos, and you're not doing like those original ones where we just had a y value, but we have several things going on each side of the inequality sign, you're going to want to find where the vertex is. Sorry, not the vertex, the x-intercepts. So notice we have x equals 3 and x equals 4.5. Alright, so remember that we're talking about inequalities and we're talking about a range of values. So if you look at, just focus on that point of 3, 0. Notice that it is shaded everywhere to the right of 3. So our answer is going to be shaded everywhere to the right of 3. And we're going to include that symbol because we have a solid line. And then if you focus just on the 4.5, just this one, it's shaded everything to the left of 4.5. So our inequality point to the left of 4.5. And then we're going to do the equal to sign because we have a solid line. So we're not looking for just x-intercepts, we're looking for a range. So what we're saying is that any answer between 3 and 4.5 should work. Sometimes you'll even see it written like this. So notice that the x is between those two numbers. So let's think of a number between 3 and 4.5. So let's say 4. If I replace these x's with 4, I should have a true statement. So let's see if that works. Alright, so 2 times 4 squared is 32, and that should be less than or equal to 15 times 4 minus 27, 33. 32 is less than or equal to 33, so this statement is true. Okay, so what I'm saying is that any answer I pick between 3 and 4.5 will give me a true statement. So it's a little bit different than those first ones we did. Okay, let's look at another one. All right, go ahead and graph this one in Desmos. Notice you have multiple things going on. Graph it in 1, 2, 3. Okay. All right, so focus on the x-intercepts. We have x equals 0, x equals 7. So if this had been an equal sign, we would be done. Because it's not an equal sign, it's an inequality, we're going to have a range of values. But I really just want you to think about focusing on just one point at a time. So look at just the 0, 0 coordinate. Notice that anything to the left of 0, 0 is shaded. So that's what our inequality sign should reflect. To the left of 0 is shaded. And then we're going to have equal to because we have a solid line. Same thing with this one. Anything to the right of 7, 0 is shaded. So to the right of 7 and an equal sign. So this is a range of values. And so what I'm saying is if I pick any number that's less than or equal to 0 or any number that's greater than or equal to 7, and I plug it in, it'll give me a true statement. I just can't pick any number between 0 and 7. Okay. So now let's do everybody's favorite word problems. I know, no one likes these, but it's a part of life. Not really. It's a part of high school. Once you get out of high school, I'm not really sure word problems are a part of anything. Okay. So, one leg of a right triangle. Draw your right triangle. That is a horrible one. Hopefully yours is better. One leg is 7 centimeters shorter than the other leg. So let's say one leg is x. The other would be x minus 7. How long should the shorter leg be to ensure that the hypotenuse is at least 13? Okay, so what you have is a right triangle. And anytime you talk about right triangles, and you're talking about all three sides, you are really talking about the Pythagorean theorem, which says a squared plus b squared has to be equal to c squared. Okay, so that's what it would be if it was a true right triangle, but the problem says at least 13. Which means it could be bigger than 13 if it needed to be. So we're going to change it to greater than or equal to. That's what at least means. So graph that in Desmos, and we'll talk about your answer. Try that in 1, 2, 3. Okay, so this gets a little confusing. So you have this point, x equals -5. That doesn't make any sense for a triangle side. So we're only going to focus on the positive one. So we're going to focus on this one that's 12. So remember, it would be x equals 12. We were talking about an equality, but it's not. So we need a range of values. And if you look at 12, it's everything to the right of 12. Okay? So this is what we're saying should be an answer. So let's pick a number bigger than 12. Let's say 13. So if I replace those x's with 13, I should get a true statement. So let's see if that happens. Okay, so 13 squared is 169. Notice that I'm not even trusting my own mental math. And then 13 minus 7 is 6. 6 squared is 36. 169 plus 36 is 205. Greater than or equal to 13 squared is 169. So that does turn out to be a true statement. So any number I pick that is greater than or equal to 12 for the shorter leg would ensure the hypotenuse is at least 13 centimeters. All right, let's do one more word problem because everybody loves them. Okay, so a cell phone company has the following cost and revenue functions. So the blue one is cost, the green one is revenue. X is the number of cell phones. If you don't know this part, sorry, that's supposed to be profit equals revenue minus cost. That's just something you're supposed to know. We're going to state the range for the number of cell phones, X, they produce while making a profit. Okay, so profit equals the cost minus the revenue, and we want the profit to be at least greater than or equal to 0. Okay, because that's how you make a profit. So put the blue function right here in parentheses, put the green function right here in parentheses, graph that in Desmos, and then we'll talk about the answer. Try that in 1, 2, 3. Okay. Mine is supposed to say greater than or equal to 0, but it cut it off. I'm sorry. Okay, so if you look at the two x-intercepts, right? So it happens anytime it's to the right of 27 point, I'm going to say 75 because we're talking about, no, let me round it to the nearest whole number because we are talking about cell phones. That makes more sense. So 28, it can be equal to it, or anytime to the left or equal to, I'm going to say 70, just the nearest whole number. So if I make between 28 and 70 cell phones, then I'm going to have a profit bigger than 0 or equal to 0. If I make like 25 cell phones, I don't make any profit. If I make 75 cell phones, I don't make any profit. And if you don't believe me, you could take the number, plug it in, and make sure it actually equals a true statement. Alright, so those are a little weird. There's an assignment on haiku. Let me know if you have questions. If not, I'll see you later. Bye.